Kirchhoff's voltage law goes like this. In any closed network, the sum of the voltage drops is equal to sum of the voltage rises. So let's say we have a closed network like this. We have few elements here. So I'm just drawing 4 of them. So let's say this one is a battery. So we have a rise here like that, and I'm writing it as E. Then we have few resistors where we will have voltage drops according to Ohm's law. So this is V1, let's say this is V2, and this is V3. So this is a closed network, single loop, so only one current. Let's say the current is I. So Kirchhoff law states that the sum of the voltage, so if we traverse the loop in one direction, this is a rise here because we are going from minus to plus. So the sum of rises is just, this is rise here. Then we have this one going this way, this is a drop, this way this is a drop, and this way this is a drop. So other three drops. So sum of rises will be equal to sum of drops. It is sometimes stated in another way, which is called that in a closed loop the algebraic sum of the voltage drops is zero. So the sum of the voltage drops is zero. Algebraic sum. And when we say algebraic sum, that means the voltage drops will be plus while the rise will be minus. So the same law, it would be algebraic sum of the voltage drops is 0. So this one, these are the positive because these are drop, and this is the negative drop, which is a rise or an EMF. So this is the Kirchhoff's voltage law, and how it comes, it actually comes from a conservation of energy basically. So if we say we have one source of energy supplying, which is the battery, and there are 3 of them which are dissipating energy. So this is the supply, energy supply, and these are the energy dissipators. So let's call them whatever, W1, W2, W3. So these are resistors that dissipate the energy supplied. So we have only one current, that means we have, let's say, I, and when we say Ws, the supplied energy will be EMF times the current, EMF times the charge. So current is I here, and just one current, so current is the Q over T. So the charge is same here, since there's only one loop, that whatever charge is going this way is going that way, and that's why we have one current. So in any cross section, the amount of charge passing through at any given time is constant in this circuit. So that's why the current is constant. So this is the supplied energy, while the energy dissipated will be, if this is voltage drop is V1, that will be V1 times Q. W2 will be V2 times Q, and W3 will be V3 times Q. So basically, if we have the supplied energy is equal to dissipated energy, which it has to be for energy conservation to be valid. So the law of energy conservation. So this is actually just this. So basically this law comes from conservation of energy. If we get rid of the Q here, we get Kirchhoff's voltage law. So that's there.